Alright lads, today we're looking at more passive house and passive design question. So we're looking at question 10 here. It's always the passive house question. So using the notes and freehand sketches, discuss in detail the importance of any two of the following in the design of a passive house. Now we're going to go through all three of them. You only pick two in the exam obviously. So building form, indoor air quality and foundation design all play massive parts in the design of a passive house. Now, building form, before we get into it, is I suppose the layout of the house and the actual structure itself and how it will add to the passive house. Okay, so look, it's crucial. First bullet point here, it is crucial in the design of both passive house and nearly zero energy buildings, right? See the sketch of the complex and simple forms, right? So we're going to have a look at these pink diagrams here for a second. In particular, these two. Okay, so you can see the dotted line here, that would be a compact form. Okay, this pink building in the middle here, this section here is taken out and put in here. What this does effectively is it raises the surface area, right? And it raises that ratio of surface area to volume. What you're supposed to have if you're going for a passive house certification is a ratio of compactness of 0.7 or less of surface area to volume. What that means really is that the house that has the same volume, well, if it's a complicated structure that has pieces sticking out of it like this fella here, well then the surface area and the amount of wall space is greater, which means that even though the two buildings side by side might have the same U values and all those kind of things, if it has a greater surface area, there is more space for air to leak out, I suppose, and also for heat to be lost. You have greater chance of having thermal bridges there in a more complex form. So if you look at this diagram here on the left hand side, this is the preferred shape, the preferred outline or footprint. Okay, it's simple, and it has I suppose, other than it being a simple practice, it makes other things easier. Like, I mean, it's easier to roof a house that has a straight roof, a flat, a simple roof. You have less time taken up for labor and things like that. Now, those aren't terribly important. Well, they are important, of course, but if I was to draw your attention down to these last two bullet points down here, these are what are really important when we're talking about the simplicity of form, right? Ideal is to achieve a compactness ratio, right? I would say it's not ideal. If you want to have a passive house, it's essential. You will not get a passive house certification if you have a compactness ratio of 0.7 or above. Okay, so if you want to build this complicated design, it's most likely that you won't get passive house certification. Okay, the compactness of a building is indicated by the surface area to volume AV ratio. We talked about that a second ago. Buildings with the same U values, air change rates and orientations may have different heating demands depending on that ratio. As I said, it might take more to heat that house because of the extra piece sticking out here. Why not, when you were designing it in the first place, put that extra area in up there? Okay, it has the same volume, it's the same size of a house, except that the surface area is smaller. Okay, easier heat. Now, obviously, that might have a disadvantage in that you mightn't design the house that you want. As in, a passive house generally is designed for functionality and so that it performs well, whereas sometimes it may not have the most appealing layouts or whatever. Disadvantage then of your complex form: you've got your greater wall and surface area, heat lost through the walls of the roof because it's more complicated, more difficult to tape and make your details airtight. You obviously greater cold bridging areas at the wall and the floor. It's a more difficult detail. Okay, move on to the second one. So that's building form. Move on to indoor air quality. Now, I think we've covered the indoor air quality in the mechanical heat recovery and ventilation video. So we could just scroll down here and we'll have a look at indoor air quality. And our answers here are basically the MHRV question. So if you can answer the mechanical heat recovery ventilation question, you can answer this part as well. So just a quick recap, mechanical heat recovery ventilation takes out your warm, stale air and it replaces it with warm, fresh air that it heats using the old stale air. Okay, I'm not going to go into that in detail because it's already done in the other video. Okay, part 3 of that is the foundation design. Now, this is something that I suppose some fellas haven't touched on yet. And here's your foundation. Now, I'm not going to even look at the bullet points. I'm going to go down to these diagrams here. Okay, so these diagrams show me basically exactly what I need to know. These green lads here, right, they're made from expanded polystyrene, EPS. And they basically create a formwork. So you can see your hardcore down here, and in your green sections here, you have your EPS. So you buy those forms, they're in L shape there. That goes down on top of your blinding, and they create a formwork. So your reinforcing irons are inserted here, and this blue section here, your footings, they're poured concrete. Okay, those are your rising walls. Now, as you can see, there is nowhere for heat to escape here. If you follow my cursor, this might be a direction where heat would have been able to get out through the blocks and down into the foundation and down into the soil. This is not possible anymore because your foundation is essentially wrapped completely in insulation. Now, you might say, sir, there's no way that insulation will be strong enough to take that kind of a weight and that kind of a load. Well, EPS 300 is an extremely compact and strong material. Now, this is EPS 300 here, whereas the lighter green over here, where the insulation is spread over a wider area, because it's your floor, obviously, and that's EPS 100, okay? The same rules apply though. You still have your radon barrier, you still have DPC up here and stuff like that. So essentially, it's wrapping your foundation in insulation and building on top of that. Now, obviously, you can see here that this has a full filled cavity and 100 mil blocks on the outside, 150 mil block on the inside. And yes, it is spending an awful lot extra money on insulation, but it's better to spend your money on insulation than rather than trying to heat the house later on in the time. Okay, so that's your insulated foundation. Okay, we move on to part B. Use notes and freehand sketches. Discuss the importance of an orientation in the siting of a passive house and show the sun path in your sketch. Okay, so we'll move on there and scroll down. The importance of the orientation, right? So obviously we know that your best orientation is south, directly south. That's the ideal, but sure, not everyone can hit that ideal, facade would say, facing directly south. So if you could go 30 degrees off of east and west, that would be, between that range, would be the perfect orientation. Now, if you look at bullet point number 3 here, it says house one room in depth ideally to minimize or to maximize the solar gain. So that's basically saying that if you can make your house one room deep, it will be ideal. And that's not always possible. If you want to put a kitchen and a sitting room separate, then that can't happen most likely, because you probably want to have them both south facing. If you want to have 3 bedrooms and only want a single story, unless you're going to make your house extremely long, then that's maybe not possible either. Okay, so sometimes that is not possible, but in those situations, all you have to do to get it up to the passive housing is to, increase your insulation. Another point to take into consideration when the orientation of siting a passive house is to take care when you're positioning your windows. So here you can see fenestration to ensure maximum solar gain and to minimize heat loss through the fabric. So basically what you're talking about there is putting your windows on the south face and, as I said, maybe slightly east, slightly west, and having no windows on your north face. And doubling up on the insulation, right? Putting more insulation there. And the last thing there is we have to prevent overshadowing spacing from other houses 1.5 to 2.5 times the height of the building, so that you don't cast a shadow onto your neighbours. Okay, so that's the importance of orientation in siting a passive house. Okay, we move down there to C. Passive house, as shown in the sketch, may overheat in the summer. Right, you're after pumping all this money into insulated foundations. You're after pumping all the money into triple glazed windows and putting big windows on the south facade, right? You're after putting a full wall of windows in your south face. Okay, so sometimes you get too much heat, right? What can you do to lessen, or sort of discuss two reasons why the overheating would occur, and then show two design details that would reduce the possibility of overheating. Okay, so why does it occur? Right, so first one, it just talks about the weather here. Overheating occurs if the internal temperature is greater than 25 degrees for 36 days. Now in Ireland, that's not necessarily going to happen. So that's a long shot of an answer, really, in my opinion. Inadequate or no overshading of windows. Okay, so this is an important one. So you don't have a bigger overhang, you don't have a brise soleil or something like that. You have nothing to protect yourself from the high sun in the summer. Okay, so when the sun is very high in the summer and your house is directly south facing, it's getting beaten by the sun all day long, it needs a little bit of protection, and that comes from your overhang at the eaves, or else if you can't manage to get that, you'll get yourself a brise soleil, which is basically a kind of a hood that'll sit over your window. There's a diagram coming up here in a minute. Third bullet point there, you have insufficient ventilation, either natural or mechanical. I would say mechanical in a passive house, but if you have your MHRV set up correctly, then that's not ever going to be an issue. In the winter, it'll keep your place warm. In the summer, it can keep your place cool, right? It keeps it comfortable all year long. Little thermal mass, so not enough thermal mass. What you have in this situation is you don't have enough concrete, right? Or you don't have enough materials that can absorb the sun's heat, right? What concrete can do, or thermal mass can do, it can store that heat and it can regulate the internal temperature of the room and give out the heat when it's necessary. So it acts like a storage heater. So that's what thermal mass. Poor design detailing, long unvented corridors, small isolated rooms, and poor placement of windows can all add as well to the reasons why passive houses might overheat. What I mentioned there a minute ago, if you have a massive window or a massive wall of windows there, large amounts of south-facing glazing resulting in too much solar heat gain, you're spending too much money putting in too much windows, and then all of a sudden your house is too warm. Okay, so the main one there is poor design, right? So that's poor design, but all these bullet points are included in poor design. So if you want to really have a passive house, you have to be hitting all of those bullet points in the one go. So how would you reduce that overheating? Okay, so at the start we were talking about there, thermal mass, the ability of a material to absorb and store heat. Concrete floors, concrete blocks are the best ways of doing that in a passive house. Also, floor covering like tiles are better than, we'll say, wooden floors. Solar gain is absorbed by the concrete floor and it acts like a heat sink, and it regulates the indoor temperature, is what I said there a while ago. Okay. Again, talking about extending the roof, having an overhang. Okay. That's the position of the sun in the summer, and if it's been blocked by an overhang, as much heat doesn't get in through that window. Whereas in B, it's colder in the winter, and you want the sun to be coming in through the window during the winter. So you have to have a nice balance. If this extended eaves is not possible, then you need to install yourself a brise soleil. Okay, a brise soleil is this fella here. So your window is here, and this is situated above the window, and it will allow in some of the light, but not all of the light. Okay, and you'd have to add in those sketches as well. Okay, dynamic glass, okay, stuff like that. Adequate ventilation, fine. Blinds and shutters, fine. Balconies, fine. Not always possible. Okay, so those are a few bullet points there that you could add in there in order to explain why a house might be overheating during the summer and how you can stop that, right? Thanks very much, lads. I hope this helps.